US and UK militaries collaborate with Rocket Lab for hypersonic advancements. In a powerful signal of growing transatlantic defense cooperation and a major step toward maintaining strategic superiority in hypersonic weapons development, the United States and United Kingdom militaries have selected Rocket Lab's Hypersonic Accelerator Suborbital Test Electron HASTE vehicle to support the next generation of hypersonic flight testing and research. The announcement has been heralded as a significant milestone in modern military technology development, where speed, adaptability, and cost-effective solutions are increasingly essential to staying ahead in a rapidly shifting global security environment. The strategic shift toward agile hypersonic testing. For decades, hypersonic weapons and vehicles, those capable of traveling at speeds above Mach 5, have been considered the future of warfare. Their potential to deliver precision strikes across vast distances in minutes has drawn intense interest from global superpowers. However, the high cost and complexity of testing hypersonic systems have remained major obstacles, often slowing progress and creating logistical bottlenecks. Traditional test infrastructure requires months, if not years, of planning and coordination, with only a handful of global facilities capable of supporting live test flights. Enter Rocket Lab, a private aerospace firm best known for its Electron rocket, which has become a leader in the small satellite launch industry. Rocket Lab has now turned its attention to the hypersonic realm by developing HASTE, a modified suborbital variant of Electron specifically designed for atmospheric re-entry and hypersonic flight testing. HASTE is capable of carrying payloads up to 700 kilograms and deploying them at speeds of over 7.5 kilometers per second, simulating the extreme conditions encountered by hypersonic vehicles in real combat scenarios. The vehicle's flexibility, launch readiness, and lower cost compared to traditional military test beds have made it an attractive platform for both the US and UK defense sectors. With a proven launch cadence and a high degree of reliability, HASTE offers what many in the defense world have long sought: a repeatable, responsive, and commercially viable means of hypersonic testing that can be tailored to specific mission needs and rapidly iterated upon. The HyCat program, pioneering the future of hypersonic R&D. The U.S. Department of Defense, through its Defense Innovation Unit, DIU, has contracted Rocket Lab to support its HyCat, Hypersonic and High Cadence Testing Capabilities program. HyCat aims to revolutionize the way hypersonic technologies are validated by emphasizing fast, frequent, and low-cost flight tests over long, expensive development cycles. The partnership with Rocket Lab reflects this shift, demonstrating the Pentagon's growing interest in utilizing commercial innovation to solve complex defense challenges. Under the HyCat program, a particularly ambitious mission is set for 2025. Rocket Lab will launch Hypersonics Launch Systems DART-AE, an autonomous scramjet-powered hypersonic aircraft built in Australia. The vehicle is designed to fly at speeds up to Mach 7 and is 3D printed entirely from high-temperature alloys, another leap in materials, science, and manufacturing that supports more efficient design-to-test cycles. This mission will be a landmark for multiple reasons. First, it will showcase HASTE's direct inject capability, wherein the payload is deployed during the rocket's atmospheric ascent rather than on a purely ballistic arc. This method more closely replicates the flight environment of operational hypersonic systems, allowing for richer data collection and a more accurate validation of aerodynamic and thermodynamic models. Second, it represents a collaboration among the US, UK, and Australia, three key members of the Five Eyes Intelligence Alliance, further reinforcing the geopolitical and strategic unity behind this endeavor. Match TB 2.0. Building the infrastructure for a hypersonic future. While HyCat addresses the need for immediate test capability, the long-term infrastructure for sustained hypersonic research is being built through the Multi-Service Advanced Capability Hypersonic Testbed Match TB 2.0 program. Funded by the Office of the Undersecretary of Defense for Research and Engineering and led by the Naval Surface Warfare Center, Massachusetts CHTB 2.0 is a 5-year initiative valued at $1.45 billion. Its purpose is to create a modular, reusable, and affordable flight test bed that can accommodate a wide range of hypersonic payloads and mission profiles. Rocket Lab's inclusion in MATCH-TB 2.0 is a significant endorsement of the company's capabilities and vision. Under the contract, Rocket Lab is not merely providing launch services, it is deeply integrated into the program's technical backbone. The company will be responsible for systems engineering, assembly and integration of payloads, test support, telemetry, and mission execution. It is a vertically integrated role that positions Rocket Lab not just as a contractor, but as a full-spectrum partner in U.S. hypersonic development. The synergy between MATCH-TB 2.0 and Rocket Lab's existing infrastructure, including its Photon spacecraft platform and advanced in-house propulsion systems, offers the U.S. and UK militaries a clear path forward for scalable, sustainable hypersonic testing. By leveraging Rocket Lab's commercial launch cadence, the Department of Defense can now envision a future where hypersonic vehicles are tested as frequently as software is updated, a radical departure from the traditional model. The UK's role in transatlantic defense alignment, though the US Department of Defense has taken the lead in contracting Rocket Lab for specific missions. The United Kingdom's Ministry of Defense has been actively involved in coordinating with both Rocket Lab and its US counterparts. The UK's Defence Science and Technology Laboratory, DSTL, has long been engaged in hypersonic R&D, but has faced similar challenges regarding cost, speed, and facility access. By aligning itself with U.S. efforts through shared programs and industrial partnerships, the UK is seeking to close the hypersonic testing gap and ensure that its forces are interoperable with allied systems. Moreover, the UK's engagement reflects a broader strategic shift, leveraging commercial innovation to amplify sovereign capability. The MOD's investments in autonomous systems, propulsion research, and test instrumentation can now be combined with the scalable flight infrastructure provided by Rocket Lab, resulting in a feedback loop of innovation that benefits all participating nations. Future UK-specific HASTE missions have already been discussed, with applications ranging from missile defense to aerospace materials testing, global implications, and the new hypersonic arms race. This collaboration could not come at a more critical time. Both Russia and China have made dramatic strides in fielding hypersonic weaponry over the past decade. Russia's Avangard and Kinzhal systems, and China's DF-ZF and Starry Sky 2 programs have repeatedly demonstrated the strategic advantage conferred by hypersonic vehicles, namely, their ability to penetrate traditional missile defenses, strike targets with near-zero warning time, and complicate adversary decision-making. For the US and UK, the partnership with Rocket Lab and the deployment of platforms like HASTE are an answer to these challenges. They offer a means of regaining technological edge through agile development and collaboration. The emphasis on speed not just in the vehicles themselves, but in the pace of development is perhaps the most important shift of all. What previously took 5 to 10 years to test can now be iterated in months, potentially turning the tide in the hypersonic arms race. The commercial-military nexus. Beyond defense-specific applications, the implications of this collaboration extend into the commercial aerospace sector. The technologies developed through HASTE missions thermal protection systems, high-temperature propulsion, adaptive flight controls, and autonomous navigation are likely to influence future spaceplanes, high-speed cargo transport, and point-to-point space travel. Just as the Internet and GPS originated as military technologies and transformed civilian life, the innovations enabled by HASTE could have far-reaching impacts beyond the battlefield. Rocket Lab, in positioning itself as a leader in this new domain, exemplifies the future of aerospace companies: dual-use platforms, high-velocity development cycles, and government commercial synergy. With more HASTE launches planned and growing international demand for agile hypersonic test services, Rocket Lab is poised to become a global enabler of a new generation of flight. Looking ahead, as global tensions rise and technology continues to reshape the nature of conflict, the partnership between Rocket Lab and the US and UK militaries represents more than just a technical milestone. It is a strategic reorientation. By embracing commercial capability, international collaboration, and rapid iteration, both nations are signaling that they are prepared not only to match their adversaries in hypersonic capabilities, but to lead the next phase of their development. With HASTE ready for launch, the future of hypersonic testing is no longer grounded in delays and cost overruns. It's streamlined, scalable, and soon to be soaring at Mach 7 and beyond.